Hello and welcome to the Unit 2 video tutorial for Day 1. We're just looking at page 1 in the homework packet today, and we're talking about electron configuration. So if you were absent, you're probably going to need to get some extra help from your teacher outside of class to understand this. Okay. So electron configuration, I've got some examples here. We're showing you where all the electrons are. So sodium has a total of 11 electrons. 2 of them are in the 1s orbital. 2 of them are in the 2s orbital, 6 of them are in the 2p orbital, and the last one's in the 3s orbital. So if we add all those up, 2, 4, 10, 11 electrons, that's where all 11 electrons are for sodium. Okay. In order to do this, you're going to want to have your electron configuration periodic table out. There's a copy of this in the Unit 2 materials on Canvas if you lose it or if you didn't get one in class. Otherwise, you do get this in class, on quizzes, and on the test you get to use this periodic table, or a test copy of it. So let's look at number 5 together, fluorine. For number 5, fluorine, we need to find it on the periodic table. Fluorine is right here, number 9, which means it's going to have a total of 9 electrons. So I'm going to put my little marker there to know that I'm going to fluorine. So I'm going to write a note to myself as well, saying I need to add 9 electrons in total. All right. In order to do that, we can start thinking of the periodic table as electrons instead of as elements. So the first and second electron instead of hydrogen and helium. So first and second electron, 3, 4 electrons 5, 6, 7, 8, and 9. So that's where they are. So I just start at home right here, and basically you're giving me directions to fluorine south. So if I start at home, I'm going to drive to the end of the block, and I get to the end of a group right there. And I'm going to write down where I am. So I'm in the 1s2, like that. I'm in the 1s with 2 electrons. After electron 2, we come back here to electron 3 and drive to the end of the block. And that's the end of a block. So now I'm in 2s2. Okay. After electron 4, I don't come down here to electron 11. Okay, 1, 2, 3, 4, 5. So I'm going to come over here and drive to the end of the block, except I don't get to the end of this block. I stop where I'm trying to go, which is fluorine. So that's 2p5, like that. So in the 2p orbital, fluorine has 5 electrons. So 2 plus 2 is 4. 4 plus 5 equals my 9 electrons for fluorine. That's where they all are. Let's look at a bigger one. Chlorine now is down here. It's got a total of 17 electrons. So that's where I'm trying to get to, is chlorine at 17. Whoops, lost my cute little marker. Chlorine at 17, and I'm starting at home base right here. I even had some people in class draw a little house. Okay, and you've got a door, and you've got windows. Okay, so we start at home, and we're giving directions to chlorine. So I'm going to drive until I get to the end of the block, and that's 1s2. The first group of electrons are going to be the same. After electron 2, we talk about electron 3 and 4, and they are in 2s2. Remember, after electron 4, we go to electron 5, and I drive to the end of the p block, which is 2p6. Okay, so right now I am at electron 10. After 10, we come back here to 11. I drive to the end of the block. That's 3s2. Okay, so electron 12 is in 3s2. Then I go to electron 13, and I drive until I get to chlorine in 3p5. Alright, so 2, 4 plus 6 is 10, 12, 17. I have 17 total little electrons in there, 2 there, 2 there. And that's exactly what I want, total of 17 electrons for chlorine. So I know I did it right. And you'll notice that these first couple electrons, 2, 2, and then those 5, they're all in the same places because they go in that same pattern. It does get a little bit weirder as you get bigger. It's fine. Just trust your periodic table. Okay? If we're looking at titanium, for example, number 9, titanium is down here, Ti, number 22. So I know I need a total of 22 electrons, and I start at home. All right? And then it's just that same process. First 2 are in 1s. So 1s2. Electron 3, we're going to keep going down here to 2s. Okay, so the 2s has electrons 3 and 4, so that's 2s2. Make sure you're not going down here to 3s next, because after electron 4, we go to electrons 5 through 10. Those 6 electrons are in 2p. 2p6. After electron 10, electron 11 and 12. 3s2. After 12, we go 13 here. We drive to the end of that block. So that's 3p6. And right now we're at number 18. It's just like connect the dot or dot to dots when you're little. Okay. After 18, we come back here to 19 and 20. Those 2 electrons are in 4s. So 4s2. And then after electron 20, we go to 21. So that will be 3d2. Now sometimes that really bothers students because they say, why is 4s in front of 3d? There's a great, confusing, long answer for that, and it has to do with the molecular orientation in 3D space around the nucleus, that the 4s nucleus is closer than the 3D, and so it's less energy. The short answer is because after 18 I go to 19, that is 4s. That's just the pattern it goes in. That's okay. And then that's it. And that's the total. We can always check our work. 2, 4, 10, 12, 18, 22. So there's my total of 22 electrons. Okay, the last one I want to look at with you all on this page is this one, an orbital. In the Bohr model, we had orbits, where here's your nucleus, it's positive, and you had an electron moving in a perfect little circle around in this exact spot. An orbital is not the exact location of an electron anymore. It's where an electron is probably found 95% of the time. You can be 95% sure the electron is somewhere within 3s, or somewhere within that weird 3D shape. Okay. All right, make sure you're getting the notes if you were absent, and then we'll look at the next 2 pages next time. Thanks, y'all.